Welcome to part 3 of the 3-part series, 3-digit by 1-digit division. In this video, we're going to explore 3 different ways that people may represent division. We'll start with the process we've been exploring so far. 352 divided by 2. I'm just going to stick to one color for this video. So we have 352 divided by 2. So when I look at my hundreds, I know that I can put 100 in each group. 2 sets of 100, 2 multiplied by 100 means I've used up 200. If I started with 352 and I've used up 200, I have 152 left. I can exchange that 100 for 10 tens, so I actually have 15 tens. So 15 tens divided into 2 groups. We'll put 7 tens in each group for a value of 70, which means I've used up 2 sets of 70. 2 times 70 is 140, which leaves me with 1 10 and 2 ones left. So if I exchange that 10 for 10 ones, I now have 12 ones. 12 ones split up into 2 groups is 6 per group. I've used up 2 sets of 6. 2 times 6 is 12. I started with 12, I used up 12, and I have 0 left. Okay, we're going to call this method 1. Now, somebody else may have solved it like this. 352 divided by 2. How many times does 2 go into 3? 1 time. And 2 times 1 is 2. 3 minus 2 is 1. Now we're going to bring down that 5 and take a look at that. How many times does 2 go into 15? It goes into 15 7 times. 2 multiplied by 7 is 14. 15 minus 14 is 1. And we'll bring down that 2. How many times does 2 go into 12? 6 times. 2 multiplied by 6 is 12, and 12 minus 12 is 0. We'll call this method 2. The third way somebody may have written this out, 352 divided by 2. How many times does 2 go into 3? 1 time. 2 times 1 is 2. 3 minus 2 is 1, so there's 1 left over. 2 goes into 15 7 times. 2 multiplied by 7 is 14, which means 15 minus 14 will give me 1 left over. 2 goes into 12 6 times. 2 multiplied by 6 is 12. 12 minus 12 is 0. We'll call this method 3. Pause the video and ask yourself, how are these 3 methods the same, similar, and different? When I look at method 1, I know that I am representing the value of each of the base 10 blocks, and I'm writing everything out fully. So it's a value of 100 in each pile. It's a value of 70 in each pile, and it's a value of 6 in each pile. When I look at method 2, I can see a quantity listed there. I can see the quantity of hundreds in each pile is 1. I can see that there are 7 tens in each pile, and I can see that there are 6 ones in each pile. So method 2 is representing the quantity in each pile. When I take a look at method 3, I can see the same thing. I can see the quantity of hundreds is 1 in each pile, the quantity of tens is 7 in each pile, and the quantity of ones is 6 in each pile. So method 1 is showing you the representation of value, and method 2 and 3 are showing you the representation of quantity. When I take a look at what's below in method 1, I can see that I'm representing the value again. So I've used up a value of 200. I've used up a value of 140, and I've used up a value of 12. In method 2, I can see that I've used up the quantity of 2 100s. And I have 1 100 left over, and I've got 5 tens left over, so I've got 15 tens. So I've quantity of 15 tens left over. And then I've used up a quantity of 14 tens, so that I have a quantity of 1 10 left over and 2 ones. So I can see that below the line in method 2, I'm representing the quantity of what's left over. But what do those arrows mean? Well, the arrows are just bringing down my focus. So here I've got 100 left over, and now I'm going to deal with the tens. So it's just a way of bringing that into focus for you. Method 3 doesn't have all of that extra writing in there. Method 3 is simply showing you how much is left over by putting it up in these little spots here. So if I have 3 100s and I've used up 2 100s, I have 1 100 left over. So that 1 is representing 1 100, but it's also representing 10 tens. So 15 in this space right here, I'm talking about 15 tens, which is 1 100 and 5 tens. And when I'm looking at the one here, I'm saying that I've got 1 10 left over. So I've got 1 10 and 2 ones. Method 3 is absolutely the most compact piece that there is. But you have to do all of that math in your head, which is fine. Method 2 is the most similar to method 1. Method 2 is just not putting in the zeros there. It's not talking about the value there. So it's a little bit more compact than method 1. When it comes down to it, you've written a little bit less than what you would write in method number 1. You have to decide for you which method makes the most sense. You can decide when it makes the most sense based on the question that you're using. Let me give you an example of that. Which method might make the most sense for this particular question? Those numbers divide up really nicely. 2 goes into 2 one time. 2 goes into 4 2 times. 2 goes into 8 4 times. So my answer is 124. I could do that using method 1 or method 2 and end up with the same answer, 124, but it's more work. So in this particular case, method 3 makes the most sense. Method 3 will be a little bit more challenging if you have a lot of regrouping that you need to do, whereas method 1 or method 2 might make more sense if there was a lot of regrouping. You need to decide for you which method you're going to use based on the question that you're going to be figuring out and based on what you're most comfortable with. They will all get you the same answer. As long as you can explain the method that you're using, it doesn't matter which of the 3 methods you choose to use. Hopefully you found this 3-part series helpful, and we will see you in the next videos.